Okay, so we're going to look at a particular problem here. We're going to look at the equation 8x squared minus 8x plus 8 is equal to 0. Now the first thing we're going to do here is we're going to factor out the 8 because each term has an 8 in common. So can we write this as 8 times x squared minus x plus 1 is equal to 0. And you can see by the distributive property, 8 times x squared gives me 8x squared, 8 times negative x gives me negative 8x, and 8 times 1 will give me 8. So now what I can do is I can divide both sides of the equation by 8. And on the left, the 8's cancel. And on the right, 0 divided by 8 is 0. So this is the same as solving the equation x squared minus x plus 1 is equal to 0. Okay? Now, I'm going to solve this using the quadratic equation. So I'm going to do ax squared plus bx plus c equals 0 for standard form. And that tells me, well, when there's nothing in front of the x squared, there's a 1 there. So I can write a 1, and a is equal to 1. B is equal to negative 1. And c equals 1. So I'll write that here. A equals 1. B equals negative 1. And c equals 1. Now the first thing I'll calculate is called the discriminant. The discriminant tells me if I have one real root, two real roots, or two imaginary roots. If the discriminant's negative, it's two imaginary. If it's real and positive, it's, then I have two real roots. And if it's 0, then I have one real root. So the discriminant is going to be given by b squared minus 4ac, which is going to be equal to b is negative 1, so it's going to be negative 1 squared minus 4 times a times c is 1. Well, negative 1 squared is just 1, and 1 times 1 times minus 4 will be minus 4, which is equal to negative 3. So this tells me I'm going to have two imaginary roots because it's a negative number. Now, I know how to solve this equation up here. I just use my quadratic formula now, which x is equal to negative b plus or minus the square root of the discriminant, which is b squared minus 4ac all over 2a. Well, this is just equal, well, my discriminant I already calculated was negative 3, so this is going to be equal to negative b plus or minus the square root of minus 3 divided by 2a. And b is a negative 1, so this is going to be equal to a negative 1 plus or minus the square root of negative 3 divided by, well, a is 1, so it's going to be 2 times 1. Now I can simplify this. Oops, right over here. And a negative make a positive, so that's going to be 1 plus or minus the square root of negative 3, all divided by 2 times 1 is 2. So before I continue, that's my answer, but I have to keep going. So I'm going to notice that the square root of negative 3, I'll do it up in this box over here, is equal to the square root of 3 times negative 1. But I can always separate square roots with products, so this would be equal to the square root of 3 times the square root of negative 1. But the square root of negative 1 is I, so this is going to be equal to the square root of 3 times I, my imaginary number I, right? I is defined in the book as the square root of negative 1. And this is going to be, so this is going to equal to 1 plus or minus the square root of 3 times I divided by 2. So then I have two possible solutions. So this is going to be equal to 1/2 plus or minus the square root of 3 all over 2I. So that, of course, because the denominator is the same, I can add or subtract the numerators to get this back, right? So these are the same. So that tells me x is equal to 1/2 plus the square root of 3 over 2 times I, or x is equal to 1/2 minus the square root of 3 over 2 times I. So those are my two solutions. Okay, so I hope that answered your question. If it something was confusing or you're doing it a different way, please let me know and I'm happy to help out. Thanks and have a great day.